8, we're reviewing polynomials. We'll start off with some vocabulary. Then we will review graphing linear equations. And what kind of equations are those? What short little word do you see that is part of linear that lets you know what that is talking about? Ted?
Like straight, so like lines.
Lines. So straight lines specifically. And we will be reviewing the slope-intercept method, which you learned last year. So kind of be thinking, okay, what was the form for that equation? What do I remember about slopes and intercepts and how that works? So we'll be reviewing it all. But let your brain start trying to remember some of that. So beginning with vocabulary, polynomials are just things where we have one or more terms that we add or subtract. One or more terms. So we might just say 3x squared. Or we might have 7/3 x to the 17th minus 5x to the 12th plus 2.1 x cubed minus 4x plus 3. So see, I've got a bunch of terms with pluses and minuses between them. So one or more with pluses or minuses between them is a polynomial. We have special names for 3 kinds. Monomial, mono just means one. So a monomial has only one term. So it could be just 7. It could be 2.5 x to the 5th. So no pluses and minuses in it, then it's a monomial. Bicycle has 2 wheels. So bi means 2. If it has 2 terms, it is a binomial. We will mostly be working today with linear ones, which look like 2/3 x minus 4. But it could be 17x to the 5th minus x. That also has 2 terms. Tricycle has how many wheels? So a trinomial is a polynomial with 3 terms running around in it. So maybe 5x squared minus 7/3 x plus 2. There's another, and then if we have more than 3 terms, we just say a polynomial with 4 terms, a polynomial with 5 terms, a polynomial with 6 terms. There is another way, though, that we classify polynomials, and that's by the exponents in them, specifically by the biggest exponent. So the degree of a polynomial, assuming we only have x in there, is the biggest exponent. So x to the 4th plus 2x, got x to the 4th, so that exponent is 4, plus 2x, that's x to the 1st, 4 is bigger than 1, so that has degree 4. Special terms, got 4 of these. If it's degree 0, it is a constant. Or if it is a constant, it has degree 0. That is because if we are thinking about a constant, then we are talking about something like 7. But 7 is the same thing as 7x to the 0, because we know x to the 0 is 1, and 7 times 1 is 7. So that's why the x still has a 0 for its exponent, and we call that degree 0 in that case. If it is first degree, like we will be talking about today, we are going to call it linear. So that's going to be something like 2/3 x minus 4. So we can figure out how to graph it. That's x to the 1st. It would also be degree 1, even if it is not a line, if it was something like just 5x. I don't have to have something else outside of that for it to be linear. If it has, the biggest exponent is 2, it's going to be a quadratic. And last year you learned how to solve some things like, 3x squared minus 7x plus 1. If you have that equals 0, you learned the factor, you learned to complete the square, you learned the quadratic formula, but some of that was at the very, very end of the year. So you may not remember it. We're going to be reviewing it in lessons that are coming up. If we let y equal that and then try to draw a graph of it, we'll learn all kinds of things this year about graphing U-shaped graphs or parabolas. And you saw a little bit about function families with parabolas last year. Hopefully you say, yeah, we kind of did a tiny little bit for that. May not remember a whole lot. That's okay. We will review it. And the last one with a special name, degree 3. So if we have x cubes in there, we call it a cubic. Makes it nice and easy to remember. And when you did function families last year, those were those snaky looking graphs that started down low, came up and kind of did a little wiggle and then continued going on up higher. And more than that, we say it's just degree 4. We don't give it a special name. Okay? All right, let's move into reviewing how we graph some lines. And we're going to get to the shortcut way that you learned last year, but first we're going to review what always works. And if you've forgotten shortcuts, if you're on a test and you're trying to graph it, or if it's like, I've never seen a function like that before, I wonder what shape it is, we start by making a two table. So I'm going to draw my little two table here, and I'm going to plug in and see what x's and y's can go together. Now, I am going to strongly recommend that you try to always get the ones where x is 0, what's the y that goes with that, and if y is 0, what's the x that goes with that, because those two will be what we call the intercepts, one on the x-axis and one on the y-axis, and they're real helpful to be able to see what any kind of a graph looks like. So for this one, if I let x be 0, I'll plug 0 in for the x, and 2 times 0 is 0 plus 3y, so I have 3y equals 6. So everybody, if 3y is 6, what's y? And we're going to plot that across 0, x is across, it comes first, 2 and up 2, so we have this point on there on our graph, and that is our y-intercept, because it is where it crosses the y-axis. Yes, ma'am. We'll get to where we're doing that in the second way that we're doing it, but for getting the intercepts now, you can just plug in x is 0, what's y? If y is 0, what's x? If we're just doing the table here. So then, let's get rid of that 0 that I already put up there, and let's switch, and let's now say, well, if y is 0, that means we have a 0 right there. So 2x plus 3 times 0, 3 times 0 is 0, so just 2x equals 6. So everybody, what's x? That means I have the point 3, 0. So I go across first to the positive 3, and then up and down 0, and I have that. Now, two points are technically enough to say, oh, here's where the line goes. I want you to always graph at least 3, and sometimes maybe even going farther. It helps you see if you made a mistake somewhere. If you get something that bends, you've got a mistake in there somewhere when you know it's supposed to be a line. So I've got one right in the middle, one on the right. I'm going to pick something over there on the left and try to see what I would get if I plug in on that. So I will say, let's pick -3, because that'll put me over here on the left side of the graph. So to evaluate that one, I need to say, well, my equation is 2x, so 2 times -3 plus 3y is 6. And I know 2 times -3 is -6. So if I add 6 to both sides, 3y has to be how much? What's 6 and 6? 12. So y has to be? So I can plot -3, +4. So I've got at least 3 points on there, and I am going to require you must use a straight edge when you're drawing your lines. That can be a ruler, it can be the edge of your calculator case, it can be the edge of your spiral notebook or your 3-ring binder, as long as they aren't too beat up. You're welcome to borrow mine. If you do anything you borrow, though, I'm going to ask, let's start putting it on the table. I just put a little sign up on that, so I know if you don't put it away, that means somebody used it and I can clean it before the next class. So you're going to line up your straight edge. For me, it means I'm using this tool. And we're going to, anytime you draw a line, you don't just stop at your last point. I want you to draw as far as you can to the edges of your grid. So this one's going to be looking something like that. And always when we draw lines, we put arrows on both ends because the line really keeps going. Questions on that? Okay, we're going to do this in a moment the shortcut way. Before we do that, let's review a little bit about slopes and intercepts and things. This line goes downhill as I go from left to right, and in English, that's the direction we go when we read things. So that line that we just drew has a negative slope. This line, this black line is just my y-axis, and this one is just my x-axis. Remember, if it's like the red line and it goes uphill from left to right, that's a positive slope. If it is flat, horizontal, it has no slope, or the slope equals 0. Vertical lines have an undefined slope. Horizontal have no slope, or slope 0. Vertical, it's undefined, because the slope would be 5 over 0, and we can't ever divide by 0. We can't have zeros in denominators. So just we need to remember, especially the positive and the negative, which way they tilt, because that's going to help us as we are drawing our graphs of different lines here. So, some things to write down to remember. Raise your hand. Oh, now that you put it up there, yeah, I remember we had something kind of like y equals mx plus b. That looks kind of familiar. Whether you remember how it works or not, you kind of know, yeah, we did that. Good. So, we are going to try to get y by itself. And when we do that, the number in front of x is the slope. The slope is not number x. The slope is just a number. X is not part of the slope. So you're never going to say that the slope is 3/4 x. You can say the slope is 3/4. The number by itself is the y-intercept, which means on the y-axis, we go through that number. So 0, comma, whatever that number is. And let's also remind ourselves that the slope is the rise over the run. It is the vertical change over the horizontal change. And you probably remember a formula, or at least that we had a formula. You subtract the y's, because that gets you the vertical change. And then in the denominator, you subtract the x coordinates. This is as long as you know 2 points on your line. And you just have to make sure you do them in the same order there. So let's continue here. So, if y equals mx plus b is our shortcut form, slope-intercept form. That means we have to get y all by itself first. So if I have 2x plus 3y is 6, I have to start by trying to get y by itself. So 3y equals, and what will 3y equal for me? Emma? If 2x plus 3y is 6, and I change it so it's just 3y equals, what do I write down on the right-hand side? I can't hear you louder. No, 3y equals, and then we'll do the y next. But if I'm getting, if I'm trying to get 3y by itself, it's my first step there. So I'll move the 2x to the other side, I'll subtract the 2x from both sides, good, and I'll have minus 2x plus 6. And how I was confusing her was she knows we got to get to just y, so if I've got 3y, what do I do to everything to get just y? We call on this one. Divide everything by 3, and then that means I have y equals, I'm going to do this part term by term, so that I have minus 2/3 x plus 6 over 3 is 2. That means I know one point on my line. I know my y-intercept is 2. That means I know 0, 2 is on the line. So I plot 0, 2. On the y-axis, I don't go across the 2, I have to go up and down. Then it says my slope will be the number that is in front of the x. So my slope is negative 2/3, not negative 2/3 x. Want everybody just hold your arm. Which direction does that go? If it has a negative slope, just hold your arm the way that the line would be angling if the slope is negative. Okay, if the slope is negative, we read in English left to right. So negative means we're going down. So since it is negative, we are going to be going in that direction. So we are going to start at the point we know, that's our starting point. We're going to go in the downhill direction. 2's in the top, so up and down 2 and over 3. Up and down 2 and over 3. We want to go as far as we can on the grid, so we're going to go back the other direction, making sure we're still keeping the negative slope. Up and down 2 and across 3. Up and down 2 and across 3. Then we draw in the line. And I thought I clicked on that for to do the line. There we go. And arrows on both ends. And does that look like the line we just drew when we drew it with the same equation, with the table of values? Just to double check. Yep, looks pretty much the same to me. But in general, it is faster and easier to do it with slope-intercept rather than plotting points. So we're doing the steps that we just did. Don't try to write down every single word of this. Abbreviate what you need of it. Get it in the form y equals mx plus b. Get y by itself. Then b is your y-intercept. It is your starting point. So you are going to plot that 0b and be sure it's on the y-axis. Not going across. Go up and down to get to whatever that b is. But that's the point you start from. Then you are going to use the slope to get other points as far as you can across the grid. Remember, if it is positive, your line needs to go uphill. If it is negative, it needs to go downhill. If it is an integer, like 2, remember that is 2 over 1. Go up and down 2 and across 1. Not up and down 2 and across 2. It's just an integer right in the denominator to help you keep that straight. Then you're going to use a straight edge to draw your line. Even though 2 determine the line, we're going to do them pretty much all the way across just as a double check and make sure we're able to draw a nice accurate line on our graph. And again, not every word copied down on this, enough that you know what the steps are. So first one, pretty easy. Is it already y equals? The head's nodding yes. So it's in the form that we need it. Who can tell me where I need to start for this one? What am I looking at here? 1. This plus 1. The other plus 1, I've got to start with 0, 1, 1 on the y-axis. That's my starting point. Who can tell me what my slope is? What number tells me what the slope is going to be? Bryce?
It will be negative, and it'll be down 1, so that's 4.
So it will be, the slope is negative a fourth, remember not negative a fourth x. So he said going downhill, so that means this direction, up and down 1 and across 4. So we start at the starting point that we already have on our graph, up and down 1 and across 4. And that's as far as I can go on this grid that way. So now I try the other side, up and down 1, 4 and across 4. Straight edge, draw in my line. But I really, as I get my straight edge lined up there, want to draw it all the way as far as I can through the edges of my graph. So I'm going to try to stretch it out there so that it goes through this. And then put my arrows on both ends of it because it keeps going forever. Thumbs up, thumbs down. How are we with that one? Okay, let's make it a little bit harder. Well, maybe not, but this is I'm going to talk about a couple of special lines. Y equals minus x. Y's by itself, but I don't know where I start on this one. Daniel?
I can start on the
Because that is really the same as y equals minus x plus 0. So my starting point is at the origin. Everybody, what is the slope? And so we're going to think of that as negative 1 over 1. Now when we have a slope that's an integer like this, okay, negative, it has to go downhill, up and down 1 and over 1, up and down 1 and over 1, especially on your papers with a teeny tiny grid. That's a heck of a lot of little dots to be putting in there. Negative 1 is the same as negative 2 over 2, right? So when it's an integer like that, I could go up and down 2 and over 2. Going the other way, I could even maybe go as far as it's negative 3 over 3. So I can go up and down 3 and over 3 as long as I keep going in the negative direction. So now I have all of those lined up, draw my line, and basically I'm talking about the line that goes corner to corner on the graph. I want you to memorize this one along with this one. The one we just did was y equals minus x. It goes through the origin and it goes corner to corner. Makes that 45-degree angle with the axes. Y equals x is the mirror image. It goes corner to corner, but with the positive slope in there. So anytime you're graphing y equals x or y equals minus x, you don't even have to go through plotting all of those points. You just say corner to corner through the origin and draw your line. Now let's do the most complicated kind that you're going to have for now. And this is my last example of today before we start working on some homework ones together. So, who can tell me how I start on this? What was that first step that I had you guys write down? We got to get y by itself. So I need somebody to tell me what to write down as I start trying to get y by itself. Melissa? So we're going to start with 2y equals 4x minus 12. Okay, I need somebody to help me with the next step. Divide everything by 2. So 2y divided by 2 is y, 4x divided by 2 is 2x, and minus 12 divided by 2 is 6. So now I need a starting point. Rachel, where do I start? What's my first point? Okay, we're going to get there. We're trying to be here. Tell me where do I start?
Negative 6.
Which negative 6?
I mean,
You're motioning one way and saying something else. On the x-axis is going to bring me over here. Is that where you want me to be? because this is mx plus b, m is the slope, b is the y-intercept. So do you want me on the x-axis?
No, the Y.
I need to be on the y-axis, so let's get rid of that one before it confuses me too much. So I need to go to -6 on the y-axis, or 0, -6. Now my slope, is it 2x? It's just 2, but I'm going to think of that as 2 over 1. Everybody draw with your arm, which way does it tilt? It is positive 2, so it's going to go this way. So uphill, so up 2 and over 1. Up 2 and over 1. Up 2 and over 1. Getting a little bit tired of that. 2 is also 4 over 2, so up 4 and over 2 to make it go a little bit faster. Draw my line in. All the way to the edges, both directions. Arrows on both ends. It went through -6, and because it went right through 3, I know it also goes through 3, 0. It's nice if we can find and label the intercepts. Not really required right now, but a good habit to get into. We will have, especially when we start doing lots of those quadratics of parabolas, where you are expected to find all of the intercepts. Questions from anybody?